In this video, we'll look at solving a radical equation that simplifies to a quadratic equation. Let's review the steps for solving a radical equation that we went over in the last video. First, isolate a single radical on one side of the equation. Next, raise both sides of the equation to an appropriate power to cancel the isolated radical. So if you have a square root, you're going to square both sides in order to cancel out the radical. If any radicals remain, repeat steps 1 and 2 until there are no more radicals. Then solve the resulting equation. The only problem with this process is that sometimes you get an extra solution, which we call an extraneous solution. And so you have to check all your solutions in the original equation. Only those that satisfy the original equation are actual solutions. Let's get started. We want to solve square root of negative 11 plus 3u equals u minus 3. So now our radical is by itself already on one side of the equation. And so I can go ahead and start the process where I square both sides. So I'll have the square root of negative 11 plus 3u. I'll go ahead and square that equals, and then I'm going to put u minus 3 in parentheses on the right side, u minus 3 quantity squared. Now on the left side, the square root and the square cancel each other out, so I just have negative 11 plus 3u on the left side of my equation. On the right side of my equation, I have u minus 3 quantity squared. Now, you can either FOIL it out, or you can use the box method to multiply. So we have u minus 3 times u minus 3. And if I were using the box method, I would set up my box. On the top, I have u over the first box and negative 3 over the second box. And on the side, I have u and minus 3. So in the top left box, I get u squared. Top right box, I get negative 3u. The lower left box, I get negative 3u. And the lower right box, negative 3 times negative 3, gives me a plus 9. So I get u squared, combine your like terms, so u squared minus 6u plus 9. So that was just multiplying out the right side. So I have negative 11 plus 3u equals u squared minus 6u plus 9. And now I want to go ahead and solve that. I have a quadratic equation, and I know to solve a quadratic equation where I have the squared term, the regular variable term to the first power, and a constant term, I have to set the equation equal to 0 and either factor or use the quadratic formula to solve. So first thing I'm going to do, I'm going to move the 3u to the other side by subtracting it. So I'll subtract 3u from the left side. I'll subtract 3u from the right side of the equal sign. And I want to move the 11 over also. So I'll add 11 on the left, and I'll add 11 on the right. So what I have now is on the left side of my equals sign, I have 0. And on the right side of my equals sign, I have u squared. Combine your like terms, and we get minus 9u and plus 20. So you can either use quadratic formula or factoring at this point. If you're using factoring, then because you have no coefficient written in front of the squared term, you can just look for two numbers that multiply to be positive 20 and add to be negative 9. So for example, if I had negative 5 and negative 4, those multiply to be positive 20, they add to be negative 9. You could check to make sure you got this correct by multiplying out u minus 5 times u minus 4. Now I use the zero factor property. So this tells me that u minus 5 equals 0 and u minus 4 equals 0. So my solutions are u equals 5 and u equals 4. I got two solutions here, and I want to go ahead and check. And to check, I'm going to plug them in to the original equation. So to check my answers, first I'll take the u equals 5. So let me just write that out, u equals 5. So I'll plug that in. So I'll have square root of negative 11 plus 3 times 5 equals 5 minus 3. And I want to check and see if that's true. So the square root of negative 11 plus 3 times 5 is 2, because I get 15 minus 11 is 4. Take the square root, I get 2 equals 2. So u equals 5 is a valid solution. I definitely want to include that one. The other one, u equals 4, I would plug that in. I'll get the square root of negative 11 plus 3 times 4 equals 4 minus 3. So you want to go ahead and figure out negative 11 plus 3 times 4 is 1. So I get square root of 1 is 1. So I get 1 equals 4 minus 3 is 1. So 1 equals 1. So I have two valid solutions. But in order to know that, I had to check those both in my original equation, because this process can give you extra solutions. So in this case, I would list both of these as a solution, to my equation. U equals 5 and u equals 4. Let's look at one more example where we also have to check and we may get an extraneous solution. Here we have 2x minus 1 equals the square root of 8 minus x. So again, my square root is isolated already, and so I can just go ahead and square both sides right away. So I'll have parentheses 2x minus 1 equals the square root of 8 minus x quantity squared. Now over on the right side, the square and the square root cancel each other out. Here on the left side, I get 2x minus 1 quantity squared. And so I'll have to multiply that out over here. So I get 2x minus 1 times 2x minus 1. This time I'll just go ahead and FOIL it out. So I'll end up with 4x squared minus 2x minus 2x plus 1. So first terms, outside terms, inside terms, and last terms multiplied together. So I get 4x squared minus 4x plus 1. All right, so that was just a little side calculation. So now coming back to my main equation, the left-hand side of the equation is 4x squared minus 4x plus 1. Over on the right side, the square and the square root cancel each other, so I have 8 minus x on the right side. So now, let me go ahead and get the equation equal to 0. Anytime you have a quadratic, ax squared plus bx plus c, you want to go ahead and set it equal to 0. So I'm going to add x to both sides. I will also subtract 8 from both sides. And so now my quadratic will be equal to 0. I'll have 4x squared. Negative 4x plus x gives me minus 3x. And then 1 minus 8 gives me a minus 7. So 4x squared minus 3x minus 7 equals 0. Now, I could try to factor this, or I could just go ahead and use the quadratic formula. So I have a equals 4, b equals negative 3, and c equals negative 7. So if I'm using the quadratic formula, then I want to go ahead and plug it in. Just a reminder on the quadratic formula, it is x equals negative b plus or minus the square root of b squared minus 4ac. And then that whole expression is over 2a. So I'm going to plug in the numbers that I have here. I'll have negative 3, since b is negative 3, plus or minus the square root, parentheses, negative 3, close the parentheses and square, minus 4 times a, which is 4, times c, which is negative 7, all over 2 times 4. All right, so let me go ahead and simplify this a little bit. I'll have a positive 3 plus or minus, and I want to go ahead and grab a calculator, and I'll put in the part that's underneath the radical. So I'm going to have parentheses, negative 3, close the parentheses and square, minus 4 times 4 times negative 7. So I actually get 121, which is a perfect square. That if I take the square root of 121, I'll get 11, and you can check that in your calculator if you're not as familiar with your perfect squares. So I'm going to get, coming back over here, I will get 3. Oh, and I already have started writing it down below. So let me go ahead and continue with that. So I have my 3 plus or minus 11 all over 8. All right, so I want to get 2 solutions. I will have 3 plus 11 divided by 8. And I will have 3 minus 11 divided by 8. And that will give me 2 solutions. So 3 plus 11 is 14. So I'll go ahead and do 14 over 8. Click on this fraction button, convert to fraction, to get a simplified fraction. So I will have 7/4. And 3 minus 11, we'll go ahead and do that. Parentheses, 3 minus 11, close the parentheses, and then divide by 8. And we get -1 as our other solution. All right, so we have 2 solutions here. And of course, these are x equals. So these are x values. And what we want to do is we want to check our solutions. Anytime you're solving a radical equation, you need to check. So the first one, I'm going to use the x equals 7/4. So I will have 2 times 7/4 minus 1 equals the square root of 8 minus 7/4. All right, so let me go ahead and grab my calculator. And I'll plug that in. So I'll have 2 parentheses 7/4. Close the parentheses and subtract 1. I get 2.5 on the left. On the right, I'll have the square root of 8 minus 7 divided by 4. 2.5 equals 2.5. So that checks out. This was 2.5, and the right-hand side was also 2.5. So I have an equivalency. So x equals 7/4 is good. Now I'm going to check x equals -1. So I'll have 2 times -1 minus 1 equals the square root of 8 minus -1. All right, so I want to go ahead and check that. I will have on the left-hand side here, 2 times -1 is -2 minus 1, so I get -3. And on the right-hand side, 8 minus -1 is +9, so square root of 9 is +3. Now we can see that that is not equal. -3 is not equal to +3, and so x equals -1 is not a valid solution. I would not list that in my final solutions because it's what we call an extraneous solution. It comes up as a solution when I solve, but it doesn't actually create an equal expression on the left and the right in my original equation. So we call that an extraneous solution. This is why it's so important to check your solutions anytime you're solving a radical equation. So once you get your 2 solutions, plug them back into this original, and the ones that work are your final solution. The ones that do not work, you would just discard.